Problem 543, diameter of binary tree. So this problem gives us the root of a binary tree, and we have to return the length of the diameter of the tree. So the diameter would be, for this example, it would be this and this. So the distance between these two, right? So if you can look at here, it will be 1, 2, 3, right? So for this case, then it will be 3 will be its diameter for the binary tree, right? It says here that the diameter of the binary tree is the length of the longest path between any two nodes in a tree, right? And it's important that this path may not pass through the root, right? So what that means is, for example, if we were to have a binary tree like this, right? So in this case, 8, 9, the longest diameter will be from this to this, right? Because it will be like 1, 2, 3, 4, right? So the diameter of this binary tree will be 4. Okay, alright, so my solution to this problem is to use a recursion as well, using depth first search. Even though it's labeled as easy for this problem, to me it is actually harder than the most easy questions. So I'll do my best and take some time to break it down of how my code actually works, right? So as I mentioned, I have a DFS function here. So what this DFS will do is to traverse the binary tree until we reach the depth, I guess you could say, right? So let's start. So I have a result here, which is 0. So this result is what we are actually going to return. And you can see here in my DFS, I'm using a reference to this result. So whatever changes is made to this result will be reflected on to this result, which is what we are going to return, right? So here I have a left, right? So left will equals to DFS again, right? So currently I'm at this node. So if I DFS on the left node, I have to open up, right? So now I'm going to the left, so I'm here, then I DFS again, so left again. Now I'm at this node, right? So what happens now is I have entered the DFS again, and I left one more time, right? So now when I left, let me put it down. Okay, so when I left again, let me redraw everything. Go here, go down here, and go down here. So when I left again, this is actually null, right? And so is this. Right. So what happens is this left now becomes 0 because it is null, right? So if the root is null, it returns 0. Which in this case, if it traverses to the left node, this node will be a null. So this is 0. Okay, the same thing for the right node, right? It will be 0 as well. Okay, so now we check the result, right? So the result is the maximum of result, which is 0, and left plus right. And left plus right is 0 plus 0 is still 0, so result does not change, it's still 0. And then we have to return 1. So we're returning 1 plus the maximum of left and right, which in this case will be 0. So 1 plus 0 is still 1, so in this case left is 1. Right. So now we are back at node 2. Right. So we're back here, and then we're going to the right node now. Right. So over here. Okay, same thing as the left branch. Our left is 0, our right is 0. The result does not change, and then we are returning 1 plus 0 is 1. So our right node is 1. Okay, after that we return back to our root. Okay, sorry, we do not return back to our root yet. Right. We return to this node, return to our node 2, and then we calculate the result. Right, so the result in this case would be the maximum of 0, and 1 plus 1. So the result now changes to 2, because in this subtree we have found that the diameter of this subtree is actually 2, right? Because 1 and then 2. But we're not done yet. Since this is a subtree, we have to do it for the entire root, right? So let's continue. Result equals to 2, so we're returning 1 plus the max of left and right. So we're returning 1 plus the max of 1 and 1. So in this case, the max will return us 1, so left will be 2. Okay, so after that, we are done with 2, and we go back to our root. Right, so I'll erase everything. So once we're back at our root, so now we are looking at the right, goes to, so if we are right over here, so the left node, in this case, the left node is pointing to null, right? Both the left and right nodes are pointing to null, so left and right are both 0. The result will equals to 2, the maximum of 2 plus left and right. So in this case, our result does not change, it is still 2. And then we're returning 1 plus the max of 0 and 0. So this will be 0, so we are returning 1. So the right node, the diameter is 1. Right, once we're done with that, so we're back to the root node again. Right, so remember this is our root function. And then we calculate the result, maximum of result 2, and left plus right. Right. So this will be 3, and our result now changes to 3. Right. After that, we return 1 plus max, but in this case, this return does not really matter to us. We are only interested in the result, since it is at the root node. Right. So you can see I don't even use the return value of DFS for the root node. After that, once we're done, we just return the result, which in this case would be 3. Right. You can see the answer, it is the same as the output for this example, which is also 3. Right. It is a bit complicated using DFS method, but I hope I have explained well. That's all I have to show. Thanks.